Good morning, students. How are you today? Hi, Isaac, Lawrence, Irsyad, Yimi. All right. So, everyone, today we are going to learn triangles. So let's take a look at our worksheet. Now, of course, triangles is part of geometry, and geometry is a very important topic. It requires you to have visualization skills, but not only that, we need to know the properties of angles and triangles. And of course, I'm also going to teach you certain formulae. So let's just start from the basics, okay? What is an equilateral triangle? An equilateral triangle has three sides that are exactly the same. And students, can you type in the chat? Can you type in the chat, the main chat, okay? Type in the chat. What is the total sum of angles in a triangle? Can you type it in? How many degrees? Yes, correct. 180 degrees. That means if you have any triangle, you add all the angles together, you will always get 180 degrees. Can you tell me why? Or did you just memorize this? There's a reason why. There's a reason why it is 180 degrees, right? Okay, Braden is here. Very good. Now, students, there's a reason why it's 180 degrees. Because if you draw a square, oh yes, did someone raise your hand? Who knows why? Yes, Emi, why?
For me, I think is when you fold all the corners together, it makes sort of a square, and there's like a 180 degrees, a half circle in the middle.
Wow, that's very imaginative, Emi. So, I have another explanation, which is a square. Okay, look at the square, right? Or any rectangle. Square or rectangle, it doesn't matter. You know that all the angles are 90 degrees, right? So when you add all the angles together, 90 times 4 is always 360. But guess what? If you cut a rectangle into half, what do you get? If you cut a square into half, what do you get? You get a triangle, right? So 360 divide by 2, you get 180, what? So if you cannot remember 180, just think of a square, think of a rectangle, and divide it by 2. So the total sum of angles in any triangle is always 180 degrees. But for equilateral triangles, okay, how do you spell equilateral? Equilateral. For equilateral triangles, all the angles are the same. That means you just take 180, divide by 3, and you get 60. So that is fixed. As long as it is equilateral, it must be 60 degrees, okay? The next one we need to know is isosceles. 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 Now, two sides are the same. Why I spell wrongly? Why they underline my word? I didn't spell it wrong, what? Hey. Isosceles. Okay? There you go. So two sides are the same. That means two angles are the same. So let's say these two angles are A. Then this angle is B. Or maybe I call this B, A, and I call this B and B. So how do you find the angle in an isosceles triangle? Let's say you want to find angle B, right? You take 180, you minus A first. Once you minus A, you must divide it by 2. Then you'll get angle B. So this isosceles and equilateral triangles. Okay? So far, this is just a quick revision. Does anyone have any questions? All right. So let's try example 1, shall we? They say that there's an isosceles triangle. So let's draw an isosceles triangle since they did not give us a diagram. So this is an isosceles triangle. Two sides are the same. They say that the parameter is 18. Parameter is 18 cm. So if AB and A, okay, let's label it A, B, C. They say if AB and AC are 2 times the length of BC. So let's say BC is X, right? We don't know what is BC, so let's call it X. Then they say that AB and AC are 2 times the length of BC. So let's call it 2X. So find the length of BC. So they're asking you to find the value of x. Okay? So students, how do you get the parameter? By adding up all the sides, correct? So if I add up all the sides, I'll get 2x plus 2x plus x. We have 5x all together. And since they already told us that the parameter is 18, so 5x is the parameter, which is 18. So can you find x? Everyone type your answer in the chat. I give you 10 seconds and don't use a calculator. Are you able to do it? Are you able to divide 18 by 5 without using calculator? Let's see who can do it. 5, 4, 3, 2, 1. Very good, Isaac. Hey, Lawrence, can you type your answer in the main chat? Lawrence, can you type your answer in the main chat? Isaac, Amy, Braden, Irsyad, Lawrence, all of you got it correct. Well done. Huh? It is 3.6. But how do you get 3.6? Students, whenever you divide something by 5, right? Do you notice what is 5? 5 is actually 10 divided by 2. Agree? So 18 divided by 10 divided by 2. So you have, whenever you see a divide in a fraction, always remember KFC, which stands for keep, flip, and change. So I'm going to keep the first number, flip the second number, right? And change it to times. So what must you do? That means you're just taking 18 times 2, then you divide by 10. Right? You're just taking 18 times 2 divided by 10. So, one more time. If I want to take 18 divided by 5, right? I just need to take 18 times 2, then divide by 10. That will give me 36 divided by 10. So, once you get 36 divided by 10, you just move the decimal place one time. You get 3.6. So, that's how we handle the number 5. Whether it is multiplication or division, you just tell yourself, 5 is equal to 10 divided by 2. Then you can very quickly get the answer. All right. Okay, let's try practice question number 1. The perimeter of an isosceles is 18. So let's draw an isosceles again. They say that the shortest side is 4 cm. So since it is isosceles, these two sides must be the same. Find the length of the other two sides. So just find the value of x. Students, what is the value of x? Type your answer in the chat now. Wow, so fast. Isaac, Ilsia, Amy, who else? Anyone else? Lawrence, good. Anyone else? What is x? Braden, how about you? Let me ask Braden. Hi, Braden. Hello, Braden. Okay, Braden, can you tell me, they told us that the parameter is 18. So can you tell me what is x?
X is 14.
14. X is 14, ah?
No, 7.
7. Very good, Braden. Well done. So we just take 18 minus 4, divide by 2, right? 18 minus 4 divide by 2, 7. Too easy. This is too easy. Let's try the next one. Okay, before we do this question, let's talk about base and height of triangle. So this is the base. Okay, let's say this is the base. If this is the base, then where's the height? The height must always be 90 degrees to the base. Always 90 degrees to the base. Now, what if I take the same triangle and I slant it like that? Then what if I tell you that the base is over here? The height is still going to be 90 degrees to the base. Right, students? What if I tell you that the base is on top here. Is it possible? Yes. Yes, of course it is possible. Only that the height must be 90 degrees to the base. So students, let me tell you something. The base of a triangle can be anywhere. It can be anywhere as long as the height is 90 degrees to the base. What if the triangle is slanted like that? Then this is the base. Where's the height? It's outside the triangle, but it has to be 90 degrees to the base. If I take this same triangle and I will rotate it like that, and I tell you that, okay, the base is here. Where's the height? The height is here, 90 degrees to the base. So students, remember, base can be anywhere. Height must be 90 degrees to the base. So let's take a look at our question. They are telling us that AC is 8 cm. So let's label it. Always label your diagrams. BC is equal to 6. Always label your diagrams. AD is perpendicular. Okay, this is perpendicular. DA is 5 cm. Okay. Label the diagram. And BE is perpendicular to AC. They've already labeled it for us. Find the length of BE. This is what they want. They would like you to find this length BE over here, okay? Now, students, why don't I give you 2 minutes? Let's see if anybody can find the length of BE. Remember what clue I'm going to give you. My clue is that the base of a triangle must always be 90 degrees to the height. The base can be anywhere. Okay, I'm just going to give you this clue. Your time starts now. Okay, Isaac, do you believe that this is actually easy?
No.
Oh, really? Okay, you only need to know how to visualize. Then it'll be easy. Let me ask you, do you know how to find the area of a triangle?
Yes.
How?
Base half times base times height.
If you know how to find the area of a triangle, you should know how to solve this question. Okay? Let me show you this. Look at this triangle. Okay, this is a yellow triangle, right? So, can you tell me how to find the area of this yellow triangle?
Half times 8 times question mark.
Okay, half times 8 times question mark. That's very true. Half times 8 times BE. Can you tell me another way to find the area of this triangle?
Uh, half times 6 times 5.
Correct. Why? Because the base of the triangle can be anywhere, right? Yes, the base of triangle can be at the bottom, can be at the top, can be at the left or the right. Okay, it doesn't matter as long as what?
It's perpendicular to the base.
As long as the height is perpendicular to the base. Very good. So I can say that the area is also half times 6 times 5. Do you think you can find BE already?
Yes.
Yes. Okay, so what is half times 8?
4
4BE equals to, can you calculate this?
equals to 15.
15. So what is BE? 15 divided by?
4.
Can I leave my answer like that?
Yes.
Yes. You can leave your answer as an improper fraction as long as you simplify it, then you will not lose marks. Okay, Isaac?
Okay.
So was this easy or not?
Medium.
Medium. You just need to know how to visualize, right? Okay, thank you, Isaac. Well done. So students, you want to leave your answer like that, or you want to leave your answer like that, or you want to leave your answer like that, it is up to you, but I'm not going to waste time doing this because you are allowed to give your answer as an improper fraction in the exam, okay? Very good. Anyone have any questions about this? Now, do you know why I keep on telling you? Now, do you know why I keep on drawing all these different triangles for you? So that I'm trying to tell you the base can be anywhere. All right, students? Base does not have to be at the bottom. Okay? All right, let's take a look at example number 2. Example 2 says that AEF is 35 degrees. Where is it? AEF. AEF, this small little angle here is 35 degrees. BFD is 50. BFD over here is 50. And they are asking you to find ACD. ACD. This is what they want. Okay? So, students, why not we take a look? Before you start, right? uh, yeah, actually, this is super easy. I think I don't need to give you any hints. Can you type your answer now in 30 seconds? You should be able to find it. Wow, so fast. Very good. I can see Lawrence and Isaac's answer. Anyone else? Amy. Okay, I saw your answer as well. Braden also. Very good. Time is almost up. All right, let me ask Irsyad. Hi, Irsyad.
Hello.
Okay, so Irsyad, do you notice that there is a letter X over here?
Yeah,
So if this is 35, then what angle is this?
35 degrees also.
Very good. Do you notice this 90? So if this is 90, then what is this? What is this angle here?
90 also.
So tell me what workings are you going to do if you want to find the question mark?
180 minus 90 minus 35 degrees.
Correct. Was it easy or not?
Yeah,
Easy. Well done, Irsyad. Okay, so angle ACD equals to 180 minus 90 and minus 35. There you go. Done. Okay, let's try another one. This one. Okay, students, this question is not easy at all. It is not easy. In fact, it is difficult. Okay, now let's read the question first. Isosceles right angle. Okay, so take note, isosceles, right? They also say it is right angle triangle. Where's the right angle? I don't see any right angles. But you must remember, in mathematics, diagrams are not drawn to scale. So it doesn't matter how the diagram looks like. You just need to follow the information given in the question, okay? Then they say that AB is the longest side of this right-angled triangle. Whenever you have a right-angled triangle, there's always the longest side. Can you see that this is the longest side? So take note, if they say that AB is the longest side, right? So let's say this is the longest side. Then the right angle must be opposite the longest side. So if this is the longest side, that means this must be the right angle. I know it doesn't look like a right angle, but we just have to follow what the question says because diagrams are not drawn to scale. Okay, so now that we have labeled the right angle, AD is the angle bisector. What is an angle bisector? A bisector is a line that cuts it in half. Okay, you cut the thing in half. That means this angle, wait, hold on. It's an isosceles right angle triangle, right? So if that's the case, this length and this length are supposed to be the same because it's an isosceles triangle. So students, can everybody type in the chat, what is what is this angle? What is this angle, students? It's an isosceles right angle triangle. What is this angle? Yes, correct. It is 45 degrees. Well done. So I know that this is going to be 45, right? And if this is an angle bisector, that means you're taking 45, cut it into half. Cut it into half, okay? So this must be 22.5, and this is also 22.5 because you're cutting it into half. Now don't forget, this is also 45. All right, what's next? AB is 18. Okay, 18. So let's just label it as 18. They would like you to find the length of AC plus CD. So they want us to find this length. No problem. Let's try. First, I am going, since we already know that this is an angle bisector, okay, this is an angle bisector. It's cutting it into half. The angle here is the same. The angle here is the same. What I'm going to do is I'm going to draw a line like that. So I'm going to get a 90-degree line here. So once I have 90 degrees here, this angle is the same as this angle as well. Okay? This line is a line that is shared. This line is shared between the two triangles. So this length is the same length, right? So what I can say is, I can say that the triangle AD, okay, let's call this point E. Triangle ADE is congruent to triangle ADC. Sorry. Yeah, ADC, correct. So students, this stands for congruent. It means exactly the same. You are using three lines. It's not an equal sign. It is three lines. It is a congruent sign. It means that the two triangles are exactly the same as each other. They share the same angles. Okay, if you don't believe, let's check. This angle is the same. This angle is the same. This angle and this angle are the same, right? This angle and this angle is definitely the same. So they also share the same length here. It is definitely the same. So these two triangles are exactly the same as each other, okay? I'm just going to remove that line so that I can label. This and this have the same length because the angle bisector cut it into half. Cut it into half. So this and this have the same length. This and this is also the same length. Why? Because the two triangles are exactly the same. So this length and this length must be exactly the same as well. Okay? What else do we know? Okay, this is 90 degrees. Students, look. If this is 90 degrees, then this is 45 degrees. That means this must also be 45 degrees, right? Do you notice that that means this length and this length must also be the same? Because it is like an isosceles triangle, am I right? So, students, now we know that the entire length here is 18, which is what the question told us. And we know that this triangle is exactly the same as this triangle. Okay? That means all the lengths are the same. All the angles are the same. That means this length is equal to the length AE. So let's write it down. AC is equal to AE. Because these two triangles are congruent. These two triangles are congruent. Therefore, AC and AE are the same length. We also know that, therefore, CD and ED are the same length. So, what can you conclude from this? You can conclude that if you want to find AC plus CD, then it is as good as taking AE plus ED. But do you know that ED, right? Okay, where's ED? This length ED is the same as EB. ED and EB are the same. So instead of writing ED, I'm going to write EB. Why am I doing this? Because I actually know AE plus EB equals to 18. There you go. So you see, where is AE and where is AB? This is AE. Then EB is over here. So the entire thing adds up to 18, which is going to be the same as AC plus CD. So now we have managed to find the length of AC plus CD. Students, who found this difficult? Raise your hand. Me, I also found it difficult. Okay, it's not easy. I told you it's not easy. So, but does anyone have any questions? Do you have anything that you want to clarify? Anyone have any questions? If you don't have question, I have. I have a question. Can somebody tell me what is wrong with this question? What is wrong with this question? Okay, I'll let you look at the diagram more closely. Can somebody raise your hand? Tell me what is wrong. What is wrong with this question? What is wrong with this question? Can you raise your hand? Okay, let me highlight something. Can you tell me what is wrong with this question? Let me ask Lawrence. Lawrence, hi.
The angle should be 60 degrees because it's an equilateral triangle.
Correct. Thank you, Lawrence. So students, this question is difficult, but this question also has a problem with it. Because do you notice that these three lengths are the same? That means this is supposed to be an equilateral triangle. How can it be 45 degrees? It must always be 90. So everybody, there is something wrong with this question. Okay, as long as you know how to recognize there's something wrong, then that is what I want you to know. Okay? So let's try question number 4. Okay. A plus B plus C plus D plus E plus F. What do they want you to find? They want you to find this plus C plus D plus E plus F. All these angles added together. How can you find it? Never mind. I'll give you 2 minutes to think about it. Your time starts now. Students, can you type in the chat what is the most useful shape in geometry? I always repeat it, right? I always say what is the most useful shape. Yes, the most useful shape in geometry is a triangle. So students, if you're stuck, I'm going to give you a hint. Okay, just going to draw one line. So what have I formed? This iPad is not cooperating. Wait. You see, it's slanting my line. Okay, never mind. I will do this. Okay, this is a hint that I'm going to give you. I've drawn a line to form a triangle, okay? So I'm also going to label some things for you. Let's label this. Let's label all these angles. Why not I call this angle X, Y, and Z, okay? So with this line, it will become a little bit easier for you to solve it. So I'm going to give you another 1 minute. Let's see who can solve it. Okay, Braden, do you notice that there is a letter X over here?
Yes.
So can you tell me what is this angle?
Angle X.
Correct. Now, can you tell me how to find the value of angle D plus angle C? How would I find that? 180 minus which angle? X. Yes, 180 minus X. Now I would like you to tell me how to find angle Y plus angle Z. 180
Minus angle X.
minus angle X again. So do you agree that these two are the same? So that means,
Yes.
can I say that D plus C is the same as Y plus Z?
Yeah.
Yes, they are the same, right? So if the question wants you to find A plus B plus C plus D plus E plus F, what angles are we finding? Let's highlight it. We are trying to find A plus the angle B here plus the angle C and D. Instead of finding C and D, what can I find? Instead of C and D, what can I find? Which is the same as C and D.
Y and Z.
Yes. So I'm finding C and D like that, right? C and D becomes Y and Z, followed by E and F. So can you see the highlighted angles? What am I actually trying to find? The total angles in what shape? What shape is this? What shape is this?
Oh,
It's a core, what? What do you call it? How many sides does the shape have?
4. Wait, no.
4?
5.
5? Okay. Oh, okay, look at this shape. How many sides does it have?
4.
What do you call a four-sided figure? A what? Do you know what it's called?
No.
Okay, can you say this word? Quadrilateral. Can you say that?
Quadrilateral.
Yes, any shape that has 4 sides, including rectangles, including square, we call them a quadrilateral. Okay? Can you tell me what shape is this called? With parallel lines like that. Do you know what is this shape? It's a trapezium. A trapezium has parallel sides. Is a trapezium a quadrilateral?
Yes.
Why?
Because it has 4 sides.
Correct, because it has 4 sides. So is a rectangle a quadrilateral?
Yes.
Is a rhombus a quadrilateral? Do you know what's a rhombus? A rhombus is a slanted square, but all the sides are parallel. Is a rhombus a quadrilateral?
Yes.
Yes. Okay, as long as it has 4 sides. So we are trying to find all the angles in what shape? Can you say again? What shape is this?
Quadrilateral.
In a quadrilateral. And do you know the sum of angles in any four-sided figure? You don't know, is it? Do you know the total sum of angles in a triangle?
180 degrees.
Okay, let's say I have a quadrilateral, which is a four-sided figure. It doesn't have to be a square. It doesn't have to be anything. So if I draw a line here, how many triangles do I have?
2.
So what's the total sum of angles in a quadrilateral?
360 degrees.
360. Why? Because it contains
Triangles.
how many triangles? Yes, because it contains 2 triangles. So students, now you know how to find the total sum of angles in any shape. Even if I give you a 5-sided figure, can you tell me what is the total sum of angles in a 5-sided figure? 180 multiplied by 3, correct. Then if it is a 6-sided figure, then what is the total sum of angles? 180 multiplied by
4.
4. Very good. So from now on, you know how to find the total sum of angles in any shape. Okay? So, what is the answer for this? If I want to find all the yellow angles added together, what is the answer?
180.
180 is a triangle, huh? 180 is for triangle. What is this?
260.
Correct. Very good, Braden. Well done. So, students, now you can see, right? As long as you shift as long as you recognize that D and C has the same value as Y and Z, then you notice that you are only trying to find the total sum of all the angles in a quadrilateral, which will give you 360 degrees. So you don't even need to do any workings. The answer is 360. Ta-da! Any questions? All right. Are you ready to try it on your own? We have another question here, which is the same. Same strategy. Okay, students, we can use the same strategy to solve this. Your time starts now. Okay, since quite a few of you are stuck, I'm going to give you a clue. I'm going to do the same thing, by the way. I'm just going to draw a line. I'm just going to draw a line. And we are just going to call this XYZ. Okay? So what does the question want? A, B, C, D, E. Correct? They want A, B, C, D, E, and I'm going to draw this triangle XYZ for you. Now I'm giving you one more chance to solve it. Come, let's go. Okay, let's take a look at this question. Imi, what is this angle here?
X.
Can you tell me how to find the angle B plus angle E?
Angle B plus angle B.
Yes, it is part of a triangle. Yes, what do you say?
180 minus X.
Yes, correct. And what about angle Y plus angle Z?
Y plus Z. And oh,
Look at the triangle.
180 minus angle Z
What? Minus Z, is it?
minus X. Z.
Minus X, is it? Which one? Minus what?
Z.
Minus Z. You want to find Y plus Z. So you must take 180
Minus X.
Correct. Minus X. There you go. So do you agree that these two angles is equal to these two angles?
Yes.
Okay. So now you ask yourself, what does the question want? A plus B. Okay, I'm not gonna highlight B, yeah. I'm not gonna highlight B, okay? A plus B plus C plus D and plus E. So instead of highlighting B and E, what should I highlight?
Y and Z.
So what am I trying to find? I'm trying to find the total angle in which shape?
And triangle.
Yes, I'm trying to find the total sum of angles in a triangle. What is the answer?
The answer is 360.
Oh, total angles in a triangle is 360. What is it?
I don't know.
You don't know? Didn't I teach you at the start of this lesson? What is the angles in a total angles in a square?
It's 360.
What is the total angles in a triangle?
180.
Why is it 180?
It's half.
It's half of a square. So can you tell me the answer, please?
Answer 180.
You got it. Well done. So do you find this difficult?
Not really.
Not really, right? We are just identifying which angles are the same. Then we can add everything together, right?
There.
Thank you, Imi. Well done. Anyone have any questions? Raise your hand. All right. So let's try example number 3. Students, before we do this question, I'm going to introduce you a new concept. Let's take a look at this triangle. Now, if I were to slice this triangle into two, let's say you call this triangle A and triangle B. Can I ask Irsyad? Hi, Irsyad. Okay, Irsyad, I want to ask you, does triangle A and triangle B have the same height? Let's say that this is the base. Then where's the height? The height must be how many degrees to the base? Hello? Uh-oh.
90 degrees.
Yes, 90 degrees. So if I were to draw the height of triangle A, can I draw it like that? Oh, is your mic working?
Yeah, it's watching.
Can I draw it like that?
Yes.
Yes, because it's 90 degrees to the base, right? What about triangle B? Does it have the same height as triangle A?
No.
No. Come, let's draw triangle B alone. Let's draw triangle B by itself. Okay, let's imagine that this is triangle B and this is the base. Where's the height? The height is like that? 90 degrees like that? Yes or no?
No.
No. So can I draw the height here? Yes or no?
Yes.
Now, let me ask you one more time. Does triangle B have the same height as triangle A?
Yes.
Yes. Yes, it does. Okay, they have the same height, okay? Now, what is the area of a triangle? Half times what?
Half times base times height.
Okay, good. So if the height is the same, okay, let's imagine the height is the same. What is the only thing that's going to change the area?
The base. The
Yes,
different
the difference in the base is going to cause a difference in the area because the height is already the same. Half is a fixed number, it will not change, right? So the only thing that change is the base. So when two triangles have the same height, what determines their area? Their base, correct? Okay, very good. So the good news is, since the height is the same, it is very easy for us to find how the area is related to each other. For example, if I tell you that the base here is 5 cm and the base here is 2, then do you know that I can immediately tell you that the area of B is 2 units. The area of A is 5 units. Will you agree with this? Yes, yeah? Okay. You're not convinced, right? Come, let's try. Let's imagine that the height is 10 cm. So let's find the area of triangle A. Half times base times height. What do you get?
25.
Let's do triangle B. Half times base times height equals.
10.
So if you take 10 and compare it to 25, can you simplify the ratio for me?
2:5.
Can you see 2 is to 5 here? Can you see 2 units, 5 units? So do you agree that the area is triangle B and triangle A? The area for B is 2 units and A is 5 units. Do you agree?
Yeah.
Yes, very good. So now we learn something new. We learned that if two triangles have the same height, then you just need to look at the base and you can already tell how many units is the area. So what if I tell you that this triangle B has an area of 12 cm square? Irsyad, can you tell me what is the area of triangle A then?
30.
Correct. Well done. Thank you, Irsyad. Good job. Okay, so students, if two triangles have the same height, you just need to look at the base in order to tell the area. So the question says that triangle DEF is 3 cm. So let's write down 3 cm square. I'm going to draw a line here. Now, look at these two triangles. Look at the yellow triangle. Compare it with this green triangle here. Both of them have the same height because I can say that this is the base and this is the base. The height is 90 degrees. Both of them have the same height. Therefore, you can just count how many units is the base. This is 1 unit. And let's look at the dots. Look at the dots. One. Okay, let me draw it out. 1, 2, 3, 4. So you count 4. I have 4 units here. So now I already know that the area of this triangle is 1 unit. The area of this triangle is 4 unit. So 1 unit equal to 3. 1 unit equals to 3. 4 units must be 12. Next, I'm going to look at this triangle here. And I'm going to compare it with this green triangle here. Do you notice that both of them have the same height? Students, can you type in the chat? Okay, can you look at the base? Look at the base. The base here is 1. What is the base here? Can you tell me what is the, can you tell me what is the area of the green triangle? If the yellow triangle is 12, then what is the area of the green triangle? Can you type in the chat now? Okay, Isaac, Amy, I saw your answer. Who else? You can count the base. Okay, Irsyad, I saw your answer as well. How about Lawrence? How about Braden? Lawrence, I saw your answer. How about Braden? Very good, all of you got it correct. So if you count the dots, you realize that there are 3 units over there. So 1 is to 3, 1 is to 3. That means 12 is to 36. There you go. Okay? 1 is to 3, 12 is to 36. So students, if you continue this way, okay, draw another line here. Okay, let's draw another line here. You can continue to compare the triangles, right? You can continue to compare this triangle and this triangle. Then after that, you can continue to compare this triangle with this triangle because they all have the same height. Yes or no? So students, compare all the triangles one by one. Then you can find the total area of the entire thing. I'll give you 2 minutes. Your time starts now. All right, Isaac, I would like you to compare this triangle with this triangle. Where is the base? On top or below?
Below.
The base is here. Like this?
No.
No. So on top or below?
Below. On top.
Correct. So let's call this the base and let's call this the base. So where's the height? 90 degrees to the base, right?
Yes.
So we are going to draw a 90-degree line. Do both of these triangles have the same height?
Yes.
They do. So we can just compare the base. So this base is 1 unit. And what about this base?
3 units.
Okay, so what's the area of this triangle?
12.
Sorry, again?
12. I mean 9.
9, correct. Now I want you to look at the 9. Look at the 9 triangle. And I want you to compare it to this triangle. Do they have the same height? Okay, this is the base here. So where's the height? The height is here. 90 degrees to the base, right? Do they have the same height?
Yes.
So let's look at the base. This is 1 unit. What about this?
2 units.
2 units. So what's the area of this question mark?
18.
18. Correct. Great. Now we just need to find this. Correct?
Yes.
So there are 2 ways to do it. Number 1, you can draw a line here. Then you can compare this triangle and this triangle. right? So if that's the case, then what's the area here? What is the area here? Sorry? What's the area here?
I don't know.
Where's the base?
On top, below.
Okay, tell me what's the area here.
6.
Correct. Then you can compare this triangle with this triangle. So look at the base. This is 1 unit base. And this is 4 units. So what's the area here?
24.
24. Very good. Now there's another way to do it. I just want you to look at this triangle. Okay, this triangle here. Okay, the entire blue triangle. And I want you to compare it with the entire pink triangle. Do they have the same height? Yes. Where's the base? But at the bottom, at the left, or at the right?
Left.
At the left, here. This is the base. Is this the base?
No.
Then where's the base?
At the right.
At the right here. So this is the base.
Yes.
Then how are you going to compare them? If you want to compare two triangles, the base must be side by side, right?
Yes.
Okay, tell me where's the base?
In the middle.
In the middle. Okay, it's over here, right? Yes?
Yes.
So if these two are the bases, where's the height? 90 degrees to the base. Do they have the same height?
Yes.
Yes, they do. So can you tell me the total area of the blue triangle?
15.
15. So what is the area of the pink triangle?
13.
There you go. 30. So all you need to do now is to add everything together, and triangle ABC will have an area of 108 cm square. So what do you learn from this, Isaac? You must
If a triangle has the same base,
same
the-
base,
with the same base or same height, you
Yeah.
can find the area easily.
Correct. Thank you, Isaac. If the triangle have the same base, or if they have the same height, you can just compare them and easily find the area. But I think more importantly, you must learn how to identify the base. So once you identify the base, then you can compare the bases. So you must make sure that the bases are side by side. Then you can compare them. Okay, students? And the height is always 90 degrees to the base. Any questions? All right. Now let's take a look at the next one. It is exactly the same concept. So let's label the question first. They say that CX is 2 times of BX. CX is 2 times of BX. CY is 3 times of AY. CY is 3 times of AY. The area of AXY is 20. Find the area of ABC. Find the area of the entire thing. Remember, you must identify the correct bases. Okay, students, I give you 2 minutes. Your time starts now. Okay, Ilsia, first, let's compare the blue triangle to this yellow triangle here. Can you first tell me where do you want to identify the base? Which line do you want to use? The line AC, or do you want to use the line BC? Where's the base?
AC.
Good. So if you identify the base as AC, you realize that the ratio is 1:3. And do they have the same height? The blue and the yellow.
Yes.
Yes. 90 degrees to the base. Both of them have the same height. So, can you tell me what is the area of the yellow triangle? Okay, don't worry, you're stuck, right? Let's go back to the basics. 3:1, A and B. If I tell you that this is 20, what is this?
60.
Why?
Because
Because the ratio of the base is?
6:1.
Yes, 3:1. So 1 unit is 20. 3 units is 60, right? Tell me, what is the area here?
60.
Again?
60.
Correct, 60. Okay, a lot of students, right? They have problem with visualization. Just because the triangle is rotated, suddenly you don't know how to do it. Can you see that this is exactly the same? One is to 3, right?
Yeah.
Then this is what? 20 and 60, correct? Ta-da. There you go. It's exactly a duplicate of what the question is showing, right?
Yeah.
Okay, so students, next time, just because the base is not at the bottom, it doesn't mean you cannot solve it. The base can be anywhere. Okay, so the bases can be here. No problem. Okay? So now let's continue. Now I would like to compare this triangle, the entire green triangle, with the yellow triangle. So which line is the base? Yes, yeah? AC or AB or BC. Which line do you want to use as a base? The bases have to be side by side. Okay, again, let's go back. Okay, the base needs to be side by side. Which line do you want to use for the base?
C.
Sorry, again?
BC.
Correct. So the height is here, right? The height is 90 degrees to the base. So do they have the same height?
Yes.
Yes. Okay, the height is here. 90 degrees to the base. So, can you tell me the area of this yellow triangle?
20.
Again?
T.
Sorry, again?
20.
20. 20, is it?
Yes.
Wait. Do you know which triangle you're comparing? The green triangle and the...
Yellow triangle.
What's the area of the green triangle? What's the area of the green triangle? You already...
80.
Yeah, it's 80. How many units is the base?
2.
So this is 2 units. And this is how many units?
1 unit.
Tell me the area of the yellow triangle.
40.
Yes. And the answer. Tell me the answer. Final answer for the entire triangle. ABC.
100.
No.
Oh,
AB.
120.
Correct. Very good. So now do you know how to visualize a little bit better? Yeah? So remember the base can be anywhere, okay? All right. Thank you, Asian. Anyone have any questions? Raise your hand. All right. So let's try the next one. Students, they are telling you that CE is to ED. Okay, the ratio is 3:2. So we say CE is 3, ED is 2. The ratio is 3:2. AF is to FD. 7:3. 7:3. Okay? They tell us that the area of BCE is 60 cm squared, and they're asking you what is the area of AFB. Students, I'm going to give you 2 minutes. Your time starts now. Lawrence, can I ask you what is the most useful shape in geometry?
Triangle?
Triangle. Is the shaded area a triangle?
No.
So what should I do?
I tried splitting it into two triangles, but I still got stuck.
But which line do you draw? From which point to?
From D to B.
Correct. That's exactly what I'm going to do. So if you have these two triangles, right? Let's call this triangle P and triangle Q. Can you tell me the area of triangle P immediately?
40 centimeters squared.
Why?
Because the base is 2/3 of Q.
Correct. Because the ratio is 2:3. So this is 3 units. Then this must be 2 units. Very good. So we know now that this is 40 cm square. 40 cm square. So what is the area of half of the rectangle? What is the area of half of this?
Oh, 100 centimeters squared.
Okay, so the entire half of the rectangle is 100, right?
That means the other half is also 100.
Yeah, because the other half should also be 100. Okay, now let's compare triangle X and triangle Y. Can you tell me how many units is triangle X?
7.
And how
Triangle Y
many?
is 3.
So how many units are there altogether?
10.
So 10 units equals to how many cm square?
100.
Haha. So they want you to find AFB. How many units is AFB?
7.
Yes,
70 centimeters squared.
the answer is 70. Easy or difficult?
Easy.
Very good, Lawrence. Well
Easy
done.
after you explain.
Yes. But at least you knew how to draw your line. B to D. Correct. You're already correct. You're taking the first step correctly, okay? Good job. Anyone have any questions about this? Raise your hand. So the question is asking you to find this. Okay, so we just need 7 units, which is 70 cm. Raise your hand if you have questions. All right, now let's try question 8. They say that AB equals to AC. Look, it is an isosceles triangle. That means this angle is equal to this angle. It's an isosceles, okay? Then they say that this is perpendicular here, and they're asking you to find the angle CBD, given that BAC is 50. Where is BAC? BAC, here, 50. If you know that this is 50, and if we know that it is an isosceles triangle, I'm pretty sure that you can find these two angles, right? They're asking you to find CBD. CBD is this. Students, I give you 1 minute. This is very easy. Your time starts now. All right, let's take a look at an isosceles triangle, Braden. Do you agree that these two angles are the same?
Yes.
So if I tell you that this is 50, right? Then let's call this angle X and angle X. Can you just help me to find angle X? What should I do? What working should I do? In order to...
180,
Yes.
180 minus 50 divided by 2.
And you will get how much? 65, right?
Yeah.
So can I say that this angle here is 65?
Yes.
And what about this?
65.
So how do you find this?
Hmm. 180 minus 155.
Very good. And the answer is,
Uh,
you just minus 90 first, then you can minus 65, step by step.
25.
You got it. Was this easy or difficult?
Easy.
Easy. Thank you, Braden. Well done. Good job, Irsyad, Isaac, Yimi. You got it correct. Lawrence, can I ask you why you did not give me an answer for this?
I did not know how to find the angle on point C.
But it's an isosceles, so now you know?
Yeah.
Okay. All right. Let's take a look at our last question for the day. They say that AB equals to AC equals to 20 cm. Let's label the diagram. AB equals to AC. So this is a isosceles triangle. They said that BC is 32 cm. And D is on the point, or is a point on BC. CAD is 90. So let's label it 90 degrees. Okay? Now they're asking you what is the length of BD. So I'm going to call it X. Students, let me introduce you to another concept. It is called Pythagoras Theorem. There's this guy called Pythagoras. He's a very smart guy, and he actually noticed that whenever you have a right angle triangle, okay, C is the longest side, then there is a relationship between them. The relationship is A to the power of 2 plus B to the power of 2 equals to C to the power of 2. Can I ask Irsyad? Hello, Irsyad. Let me ask you something. Do you know what is 5 to the power of 2? What is the answer? Do you know or you don't know? Haven't learned before, right?
Is it 10?
Good guess, good guess. Okay, because of the number 2, right?
Uh,
Okay, you thought it is 5 times 2, but it is not 5 times 2. The number here is simply telling you how many times must you multiply the same number. So in this case, we just multiply 2 times. What do we get?
25.
Then what about if I take 5 to the power of 3? What does it stand for? 5 times what?
5 times 5.
Correct. So it is simply telling you how many times must you multiply the same number. We call it power. Okay? So let's do an experiment. Okay, with Pythagoras triangle. Okay, you have a right angle triangle, and Pythagoras says that a square plus b square equal to c square. For example, I say that a is equal to 3, b is equal to 4, and then we can say that c is equal to 5. Okay, so let's do an experiment. A square plus b square equal to c square. Let's see whether this is true or false. What is 3 to the power of 2? What is 3 to the power of 2?
9.
What is 4 to the power of 2?
8.
No. Again?
Oh, 16.
What is 5 to the power of 2?
25.
So is this equation true?
Yes.
It works. Correct. Let's try another experiment. What if we say that A equals to 6, B equal to 8, C equal to 10. Let's see whether it works. A square plus B square equal to C square. What is 6 to the power of 2?
36.
8 to the power of 2
64.
equals to how much?
100.
Does it work?
Yeah.
Yes, it works. So now I'm going to do this. I'm going to say that A is equal to 5, B is equal to 12. Then I'm going to put a question mark here. So what can I write down? 5 square. Oh, by the way, we call this square also. This is called power, right? Power of
Yeah.
2, right? But we can also call it square. Do you know why we call it square? How do you find the area of a square? Okay, let's say you have a square.
There's
How do you find?
one side times one side.
Okay, very good. So if the side is 5, right? Then you take 5 times 5, right? Do you notice that this is 5 to the power of 2? So whenever you put power of 2, right? You know what will you get? Any number to the power of 2 will give you the area of a square. Do you agree or not? Because you take the same number, multiply 2 times, you get the area of a square, right? So that's why we call it squared. Okay, so sometimes we can call it squared. Then we don't need to say power of 2. We can call it squared. So if I say that A is equal to 5, B is equal to 12, I do not know what is C. I do not know. So I'm just going to write down 5 square plus what? What else?
12
12 what?
square.
Equal to C squared. Now we are trying to find C. What is 5 square?
25.
What is 12 square? 12 times 12. 100 and
144.
correct. So now what do you get? 1225 plus 144 equals to 100 and
69.
okay, do you notice that C square is actually 169? Can you think of a number when you multiply itself, you can get 169? So for example, 10 times 10, can or not? 10 times 10 is not 169, right? 11 times 11 is also not 169, right? 12 times 12 is 144. So what number can we use? Multiply together, then get 169. It's not 10, it's not 11, it's not 12. What else can we try?
13.
What's 13 times 13? 169. You got it, okay? So 13 times 13 is 169. So what can I say that C is equal to? So what is C equal to? Okay, C square equal to 169, right? What is the meaning of C square? C times C, right?
Yeah.
What is the meaning of, how do you get 169? 13 times 13, right?
Yeah.
So what is C? C equals to?
13.
13. So can you see? 5, 12, 13. Okay? Very good. Thank you, Irsyad. You got it. So students, this is Pythagoras theorem. Can I test you? Okay, everybody, let me test you. I'm just going to draw a triangle here. Okay, then I'm going to call this, I'm going to say that this is 10 cm. This is 6 cm. Can you find what is this angle? A square plus, what is this length? Find what is this length. A square plus B square equal to C square. Everybody, can you calculate what is this length and tell me? Type your answer in the chat, please. Very good. All of you got the correct answer, which is 8. Okay, so you actually, how do you do this? 6 square plus, let's just call it B, okay? B square, A square plus B square equal to C square. So 36 plus B square equal to 100. B square should be 64. So if B square is 64, then you ask yourself, 64 is 8 times 8, correct? B square is B times B, correct? So B must be 8. Okay, good. So now everybody knows how to use the Pythagoras theorem. We are going to use it to find the length of we are going to use it to find the length of one of the sides. Okay, so I would like everybody to look at the triangle. Okay, I'm going to draw a line here. So I'm going to make this 90 degrees, and I'm going to call this point E. So I would like you to look at this triangle, everybody, this yellow triangle. And I would like you to tell me, everybody in the chat, what is this length? I've actually drawn a line to cut it into half. So can you tell me what is this length, please? Correct, Isaac, 16. Because I cut it into half. 32 divided by 2 is 16. So I know that this is 16. I know that this is 20. Now I want to find this. So if you use Pythagoras, right, we can say that a square plus b square equal to c square. So everybody, I give you 2 minutes. Can you just calculate what is the length of A? What is the length of A? Well done, everyone. You got it, okay? The answer is 12, right? So how did we get that? We are just going to write down the workings. We are going to say, by Pythagoras theorem, we know that a square plus, you see AE, right? This is AE, right? AE square plus 16 square equals to 20. 20 squared. So we are going to say that AE squared equals to 20 squared minus 16 squared, which will give us 400 minus 256, 144. So therefore, we can say that AE is 12, because 12 times 12 is 144. Good, now we got this. Next, let's look at another triangle, okay? Let's look at the triangle AED, this triangle here, AED, the green triangle. It is once again right angle. It is a right angled triangle once again. So we can say, oh, by the way, if this is 16 and this is 32, that means this length must be 16, right? Students, can you type in the chat? What is this length? What is this length? If this is x, okay, let me label this is x, huh? And this is 16. Can you tell me what is this length here? Type in the chat now. Correct, Isaac. 16 minus x. Well done. 16 minus x. So if you look at the green triangle, we know that this is 12, which we have just found. We know that this is 16 minus x. So now I'm going to try to use Pythagoras to find this, to find the length of AD. Okay? So we are going to say that 16 minus x and 12. Okay. So now we are going to say by Pythagoras theorem again. By the way, we have to write it down whenever we are using it so that the teacher, the examiner knows that we are using Pythagoras, okay? We are going to say that 12 and 16 minus x. Okay. A square plus b square equals to c square. A square plus b square equals to c square. Now, this is a little bit of algebra. Okay? Let's do this first. 12 times 12, 144. And when you see 16 minus x to the power of 2, that means you must multiply it by each other. You must multiply it 2 times, okay? So how do you multiply 2 times? You just do it step by step, 1 at a time. Take turns to multiply 1 at a time. 16 times 16. Let's write down 144 first. 16 times 16, which is 256. Then after that, we're going to take 16 times negative x. There's a negative here, be careful. It becomes minus 16x. Then we're going to take minus x times 16, which will give you minus 16x again. And finally, minus x times minus x. Students, minus and minus will give you positive. Negative and negative give you positive. X times x is x squared. That means x to the power of 2. Okay? And that will equal to AD squared. So let's just simplify everything. Yeah, let's just simplify everything. Let's add this together. And let's add this together as well. So we are going to say that AD squared is equal to this plus this is 400. Okay, let's start with the highest power first. X squared minus negative 16 minus 16 will minus 32. And then this will become 400. Okay, so now we have AD squared equals to this. Next, let's see. What else can we do? Let's use another triangle. Let's use another triangle. I'm going to use the biggest triangle. Let's use the biggest triangle now, which is also a right angle triangle. So I can use Pythagoras. A squared plus B squared equal to 32. C squared. ABC. Okay, so I'm going to do by Pythagoras theorem again. I need more space. Wait. I can make more space. Okay. Again, by Pythagoras theorem. I'm lazy, so I'm just going to copy. All right. By Pythagoras theorem, we will say that 20 squared plus 20 squared. Wait. 20 squared plus 20 squared is 32 squared. That doesn't seem right. Okay, let me take a look. You see, how can 20 squared plus 20 squared equal to 32 squared? That means there's something wrong, okay? So I know what is wrong. I'm looking at the wrong triangle. I'm looking at the wrong triangle. I should not be looking at this. I should be looking at the right angle here. Right angle here is, they say that it is angle CAD, right? So let's look at the entire triangle. This one, the blue triangle here, CAD. This triangle here. All right? That means AD squared plus 20 squared equals to 32 minus x. This is 32 minus x squared. So let's write it down. We are going to say that a squared plus, where is it? 20 squared plus AD squared equals to 32 minus x squared. Okay, so therefore we can say that AD squared equals to 32 minus x. When I multiply them together, I take turns to multiply one by one, like this. What will I get? Okay, I'm just doing it in my head right now. 32 times 32 minus 64x plus x squared. Okay, I'm doing it in my head because I don't have space. Now, this is AD, right? Do you notice that this is also AD? This is AD. This is AD squared. This is also AD squared. So they are the same. They are the same. So I can just cancel. I can just write them x squared minus 32x plus 400 equals to x squared minus 64x plus 1024. Cancel away the x squared because it appears on both sides. We realize that 32x, okay, when you bring this over to the other side, what will happen? Let me show you something. 5 minus 3 equals to 2. If I want to take this and bring to the other side, is this correct? This is wrong. How do you make it correct? The negative will become positive. Negative become positive when you bring something the other side. So when you bring this the other side, the negative will become positive. Okay, so you have 64x here minus 32. That will give us 32. 64 minus 32 is 32. Now you bring this over to the other side, it will become negative. So you end up with 1024 minus 400, which is equal to 624. Therefore, x is equal to 624. Hold on. Hold on. Okay, students, I think we missed this out. Okay, so we are supposed to find AD square, right? So I need to bring this over to the other side, and it will become negative 400. So let's just write it down. Negative 400. Okay, so then I can say that this is the same as this, because both of them are AD. Both of them are AD squared. So they are the same. So I'm missing out the negative one. So this must be 224. So x is 224 divided by 32, which is 7 centimeters. Okay, what a long question. But students, you do not need to understand everything. Okay, just understand the basics, which is A, B, C. A, B, C. A square plus B square equals to C square. How many of you found this question difficult? Raise your hand. I know it is difficult. Okay, so students, well done today. We have completed the worksheet. Not only did we learn Pythagoras theorem, we also learned about triangles with the same base or the same height, right? And we also learned basic things: equilateral triangle, isosceles triangle, how to identify angles. So what do you need to do to improve your visualization skills? What you can do is you download the empty worksheet one more time, and then you look at the diagrams. Remember what is the most useful shape in geometry? Triangles. Think of what lines can you draw to create triangles. Then it will make your life so much easier. All right, students. Okay, so Irsyad, I just need to ask you a question. Can you stay for a while? The rest of you, I'll see you next week. Bye, everyone.